Welcome to Chemistry Lab. Today's lab, acid-base reactions, part 2. This week we're going to be doing a titration again, but there are two differences between what we were doing last week and what we're doing this week. One difference is that we're going to use a weak acid instead of a strong acid. Our weak acid is going to be acetic acid that we'll get from vinegar. Acetic acid. The second difference is that we're going to allow the LabQuest probe to build the titration curve for us. Last week, you had to take each point and then graph that by hand. This week, as I say, we'll use the LabQuest to build titration curve. Again. One important point is that when you get to the titration curve and you need to get a file off of the LabQuest probe, make sure that you really get the file off the SD card. There's a little symbol SD at the top of the LabQuest device, and if you don't see that, that means that the SD card is either missing or is not seated appropriately. See one of the assistants to make sure you get a LabQuest device with an SD card. Because if you run the experiment without pulling up the right file, you can wind up having to redo the experiment because it does something entirely different. So we don't want that to happen. Make sure you get the experiment off the SD card. If we look at the steps of what we're doing this week, first of all, same thing that we did last week. We have to prepare the sodium hydroxide solution for the titration. Prepare strong base, and you have to dilute it from a more concentrated solution, and then you have to standardize it. Standardize strong base. And you do this the same way that you did it last week. We use KHP. You weigh out the right amount of that, run through the titration, do it at least twice, have your results agree with one another by about 5%, and you're good with the standardization. So this is exactly the same as what you did last week. Then we need to prepare the weak acid solution. Once again, you're going to use a pipette. And this week you'll also use a volumetric flask for the dilution of vinegar because we can't run it straight out of vinegar. It's a little too concentrated. We have to dilute it down. But you're going to prepare the weak acid solution. You're going to calibrate the pH probe. And that's exactly like you did it last week because we got the same setup, right? We're going to have our vinegar solution in the beaker with the pH probe, and then we're going to have the burette with our standardized strong base solution that we'll be adding to the solution. And then we run the titration. We're going to titrate the vinegar solution with the strong base. So the LabQuest device is going to be building a titration curve for us, but we can predict that the equivalence point is going to be in a different location here. Last week when we did the strong acid, strong base solution titration, the equivalence point was at pH 7. But let's think about what's happening this week. We have acetic acid, and we're adding a strong base to it, right? Hydroxide ion to this. So what's going to happen here is that we'll generate water and acetate ion. It's the acetate ion, which is a weak base. This will set up an equilibrium in water. Right? Acetate ion plus water at equilibrium. We're going to make acetic acid and hydroxide ion. Now, let's think about what this means here. The first reaction is representing what's happening in the titration itself, right? The strong base that you're adding is reacting with the vinegar in solution. Every time that happens, we're generating some acetate ion, which turns around and undergoes this equilibrium with water and we're generating some hydroxide solution every time this happens. So when these amounts, the number of moles of acetic acid and the number of moles of hydroxide, strong base, whenever these amounts are equal, we have leftover hydroxide ion in solution. So from that, we can predict that our equivalence point should be basic. So when we look at our titration curve, all right, pH versus volume of base, right, it starts out low, and then it does this, and it does this. The equivalence point is still this inflection point, but we can predict that this inflection point ought to be at a higher pH. It ought to be at something greater than pH equal to 7. Now, once we know what that inflection point is, you're going to take the graph, right? You're going to find this inflection point. You can see the number, the volume of base, the number of milliliters of base that it took to reach the inflection point. And because you know the concentration of base, concentration times liters is equal to moles of base. Right? That's what you got from the standardization. And at the equivalence point, moles of base are equal to moles of acid. Now that you know the number of moles of acid, you can use that to divide by the liters that you used in the experiment to ultimately find the concentration of acetic acid in the solution, and then work backward to find the concentration of acetic acid in vinegar. And that's ultimately what we're after in all of this. We're looking for the concentration of acetic acid in vinegar. One other note, time can be a factor in this lab. I recommend that you spend the first hour of the lab doing the strong base preparation and standardization. Think of the second hour of the lab being used to prepare the acid solution in the pH probe, then the last hour of the lab for the titration itself, and you should be able to get it worked in. I believe that's all you need. Have a great lab.